Yes, it's working. Okay, so I understand this is a joint meeting of Lancaster, Manchester and Liverpool, and you are mostly PhD students. That means young researchers at the beginning of career, open-minded, searching for directions, which is the most rewarding people to speak to. Still long time that I can influence you. So I'm glad that I can have your attention for the coming 50 minutes or so. The subtitle of my lecture could be, the title is a bit long, that's not really it, but the subtitle could be How Mankind Does Not Learn from History. This will be a historical presentation, and you heard already, I've been around for 30 years, even more. So I can talk about history. For me it's the past, for you it's the future. So that's a nice thing that I can have the chance to tell you my experiences, that you can use it the rest of your life. But probably you're going to make the same mistakes. Your generation will probably repeat all the mistakes that my generation made when we were your age. But I'll tell you about it and warn you for that. And one common problem, mistake, and I'll try to make that clear in my lecture, is that the disconnect between theory and data. Often people working on theory don't know very well what the empirical findings are, and working a lot on theory that is a waste of time, that could have been done much better had they known better data. And also in data people are working on things, and if you know a little bit about theory, you know it can't work. So in general, that the two kinds of people get more awareness of what the others are doing is a general recommendation. One of the things that my talk about history hopes to convince you of. Another point that will come out, Homo economicus is not Homo sapiens. Homo economicus is usually the standardized, stylized individual agent assumed surely in economic theories in the past and also today, but in many ways deviating from how people really behave. The real consumers are Homo sapiens. They have other properties, and in the past has been too much ignored that this difference is too big to let it be. And now the behavioral approach in economics, well, it's getting more and more popular. You hear it everywhere. Everybody's putting behavioral in the title of the paper, whatever they are doing. But still, it's a good tendency. That is the tendency to assume, make more empirically realistic assumptions about the agents in your model, to get them close to Homo sapiens. Then you can better predict what is happening, what your consumers are doing, or stakeholders, or whatever you're talking about. So here is then a cartoon, a bit funny, but it says, those who don't study history are doomed to repeat it. Those who do study history are doomed to stand by helplessly while everyone else repeats it. That's a little bit, you can tell people. But I should emphasize, it says here, everyone else, so not you. You guys, I can warn today, so you guys will not make the mistakes that my generation made. So that's at least 100 people, saves a lot of time. So I hope I can convince you of many things. And stand by helplessly is a bit passive. You will be working active. You will not be standing by. So the topic of this lecture, more concretely, it will be the history of risk and uncertainty. Decision under risk, decision under uncertainty. I'll talk about that history. That will lead there. I will show you how the behavioral approach came into being. And that will also give lessons for the future. That's a little bit what I will do this lecture. Now I talk about risk and ambiguity, risk and uncertainty, or ambiguity. Well, I'll explain the terms later. One reason is that is my expertise, so I can best tell you. For more than 30 years, that's what I worked on. So I saw the history, that's one reason. Another reason is that the behavioral approach started in risk and uncertainty, how to model that. That's where the first behavioral ideas came. Later they spread around to other fields. And now almost everywhere in economics and management science, everywhere people start using it, which I like, which is a good development. But also in risk and uncertainty, I think the ideas have been most developed, are most mature. So that's another reason. So in this lecture today, you will learn things about how to model risk and uncertainty. That's one thing. But many things that I tell you for risk and uncertainty hold generally true, just as much for intertemporal choice, well, I understand this is a diverse audience. Many fields of economics are represented here. In many fields, welfare, evaluations, the same things are going on that happened in risk and uncertainty. So you will hear, I hope you will also capture those general principles, like the disconnect between empirical and theoretical, that is often a problem. And then the behavioral principles that I explained to you for risk and ambiguity, they hold similarly in many other fields. So I hope that you will learn about risk and uncertainty, but also a few general ideas that may also be useful in your field if you're not working with risk and uncertainty. So part one of my talk, that will be the biggest part, the history of modeling risk attitude. That will be a story of my generation. Most of what I tell you here happened between the 1970s and 2000, roughly, those 30 years. Part two will come later, near the end, will be how to model uncertainty, ambiguity. I'll explain what it means. Well, risk means that probabilities are given. Ambiguity, uncertainty means you have lack of information, but you can't express in terms of probabilities, unknown probabilities. One reason that people only recently started studying ambiguity and uncertainty, which comes in the last part of my talk, is before people didn't know how to handle it. It was difficult. Although everybody has always understood it was important, people just didn't know what to do. So long time in my generation, it was usually risk. But now, new good models for ambiguity, for unknown probabilities have been developed, and more economics, everybody is starting to use those models. So that will be for your generation to work on. Then maybe you can learn what we did wrong in my times. In this first part, and then also the second part, there will be two lines that I'll be following, one and then two, and so two lines. Two questions that I keep on discussing for this first part. The first question is, how in general, this is a general question, if you want to model risk attitude, how should you do it? What kind of theoretical concept should you use? In particular, should you try to do it through how people feel about outcomes, the utility of commodities or whatever the outcomes are? Is that a good theoretical tool to capture risk attitude? Or maybe is it better that you do something with how people feel about probabilities, that you do some theoretical thing with probability transformation, things like that. I'll show you more what these things mean, but that is one topic of debate that I will show you how this developed through history and made it until today, and then future is for you to do. The second question that I will keep on discussing, returning to, I go between the two lines, is not so much how in general you model this risk attitude, but what empirically risk attitude is. What are the important phenomena? What should you try to model? And in particular, I will focus on 2 points. In risk attitude, can we say that risk aversion, dislike of risk, that is a universal pattern, so that everybody, Homo economicus, Homo sapiens are like that, they just don't like risk. Of course, there's always a bit of deviation, but maybe that deviation is just a bit of noise and not very serious, and we can, in general, assume risk aversion. Is that a good way to go? Or should we be more openly, is it too much violated to assume? And should we look at a more diverse pattern, whereas people are sometimes, in the majority of cases, people are risk averse, but maybe sometimes people are so much risk seeking that we have to incorporate it in our models. So the second question is risk aversion, can we assume it's universal, or must we really relax that assumption? Those two things I'll show you how in history thoughts have developed and where we are nowadays. Well, sure, I should give a definition. Definition of risk aversion, and maybe you remember from a Micro 1 class long ago. Risk aversion, a lottery, that's a probability distribution over money. I call that lottery. You can look at the expected value of the lottery. If you always rather get the expected value of the lottery for sure, rather than the lottery, that is risk aversion. So a preference for certainty, rather if two things have the same average, then you rather have the sure average. You don't like the risk. So risk aversion, as I define it here, that's a property of preference relations. So that's the definition, the most common one. The classical theory, always long time, almost always used in economics and many other fields for risk is expected utility. And Bernoulli introduced it long ago. Here is a lottery, as I call it, a probability distribution over money. With probability P1, it gives you £1. With probability Pn, it gives you Xn pound. Probabilities are non-negative, they add to 1 always, you know these things. So probability distribution over money. Then here is the expected value of that probability distribution, the expectation. But Bernoulli said we should not look at the expectation, but we should we should look at expectation, that's a good thing, but not expectation of money, but expectation of the value, the worth of money. So he said, we take the utility values of all the money amounts, and of that we take the expectation. That's a good way to evaluate lotteries. And if you must choose between lotteries, maybe risky decisions, how do you save money, to do the thing that gives you the highest expected utility. That was his recommendation, and it's still by far the most used model in economics. Then here that capital U is a subjective index of risk attitude. Subjective means it depends on the agent. Different agents have different risk attitude, different interests, money has different value to them, different people can have different risk attitude, and the capital U, that completely captures the risk attitude of the agents. That's what's assumed here. For example, classical, well-known results, and maybe somewhere in micro they must have told you about this. Marshall mostly proved in 1890. He showed risk aversion. You remember, you rather have the expected value than the lottery. Risk aversion holds if and only if utility is concave. So diminishing margin of utility. These two are equivalent. And maybe, I don't know, if you know it well, then you don't think about it. If you first hear it, you may be surprised, because it feels a bit weird. Risk aversion is about probability of risk. Concave utility is how much you like money. How can they be? It feels a bit strange. But then he proved it mathematically, and there's no arguing with logic, so what can you say? So that's a well-known theorem. And it illustrates that here the utility function is telling you what risk attitude is. The utility function is doing it. Many other things have been done with utility function, the index of risk aversion, all kind of thing. There's a whole insurance literature showing all kind of properties of utility, give all kind of precautionary saving, God knows what. A lot of it is done. But this is the common model in economics. So now, line 1 of my talk, I told you the general question, how should we model risk attitude in general? Should we model it by a function operating on outcomes? That is utility of money. That's what we're doing here. Or maybe do it differently. By the way, I forgot a practical point. Any question is always, you need not wait till the end. If you have a question, can raise finger. That may be nice. So whenever, do it. So we're going to discuss this a bit more. Because here is an alarm bell, and Psy means psychologists. Behavioral economics is a typical thing of behavioral economics to get Homo sapiens. Psychologists know a lot about Homo sapiens that economists know less so, but that is really useful for economics. So behavioral economics, you could say behavioral economics means bringing in more psychology into economics. And that also in this history that I tell you, it proves really were the inputs of the psychologists on many situations. Only thanks to them could we make progress, and could economics also get good models of risk as we have nowadays. Here was an intuition that from the beginning came from psychologists. When they saw this result, and in general, but this thing, risk aversion, if and only if utility is concave, psychologists say, hey, wait a minute, that's weird. The thing I said a moment ago said, every psychologist felt that from the beginning. Already in 1948, 1950, psychologists were writing what I say now, what I said before. Utility is how you feel about money, how much happiness moneyness brings in your heart, let us put it that way. That is utility. That is a very different part of your brains than risk attitude, how you think about risks and probabilities. These things feel so different. How can it be that they are equated in a theorem? If a theory equates them, probably there must be a problem with the theory, because they can't be the same. That's the reasoning that psychologists from the beginning adopted and were sympathetic to, and economists not at all. So maybe some of you are feeling, what nonsense is this? That's what the most economists thought for 30 years. But psychologists from the beginning were using reasonings of this kind, and I think these are good kind of reasonings. So, well, because a problem with this is just reasoning about feeling, how do you, there's nothing observable, you know. Economists want observable choice. Then it's well defined, the rest is nonsense. Psychologists are less strict in that regard, and I think one of the lessons of behavioral economics is we should loosen up on that reveal preference paradigm, but psychologists from the beginning were thinking this way. Anyway, and as you will see, this kind of reasoning did bring goodness, improvement. It was worth that it was done, that people were doing it. But for a long time, until the 80s, nowhere in the economic literature you could find such things, only in psychology literature. So psychologists said, risk attitude is how you feel about probability, not how you feel about money. So we would like to see formulas and theories that say something what you do with probability to give risk attitude, not what you're doing with money, not how you feel about money, but how you feel about probability. That seems to us a better way to model. So psychologists, they said, look, here is the formula that economists are doing, that capital U is operating on money. We think that can't be risk attitude. We think this looks like a formula that can capture risk attitude. Here we are doing something with probabilities. We're trying to model how people feel about probabilities. And we think that is more likely, more plausible to capture risk attitude. So psychologists from the beginning, from the 1950s on, and even every psychology student learned in the textbook section with such a formula. This was common thinking in the psychological literature. Nothing of it appeared in economics. So that W function, how you feel about probability, a few properties are natural. W will be 0 at 0. 0 probability cannot happen. No weight for it. We normalize it to be 1 at 1. Probability 1 has all the weight, just normalization. It will be increasing. The bigger probability, the bigger weight. Some natural conditions. So there's a curve what the function might look like. And here is, for instance, Lola Lopes, a psychologist. She wrote about this in 87, but also 50s, 60s. She said, risk attitude is more than the psychophysics of money. That's psychological terminology. Psychophysics is studying if you put some water on your, cold water on your skin, how much coldness do you feel? Maybe if there's a little electrical shock, how much pain does it do? So how stimuli generate feelings, that is psychophysics. And psychologists said utility is just the psychophysics of money. If you get money, how much happiness do you feel in your heart? How glad are you with that money? That's utility of money. So psychophysics of money, that was her way of saying utility. And so many people argue this way. Here is a psychologist already in the 50s. He was doing many empirical studies to measure that probability weighting function, to see what properties it has, to see how it is related to risk attitude. There was a lot going on. He was one of the first, influential, nice work he did. Several psychology authors did it too, not economists. But the arguments, the kind of vague talking, feeling, what is it? Intuitive, there's no how theory, how can you observe? That may be a bit of a weakness. So economists never liked it very much. We're not much interested. And these theories that the psychologists were having, I think there was this intuition they had was right. We should go that way. We have gone that way. Still, for a long time, these theories didn't go far. They were not used very much. Something apparently was wrong with it, and the psychologists were not well aware what was wrong with it. There was a good intuition, but still there was something else wrong. Anyway, I'll come back to that, but now I'll go to the other line, so I have 2 lines. I'll continue on this, but now I'll talk a bit about the other thing. Risk aversion, is it universal? So now I don't discuss so much how do you model it. Now I discuss what are the empirical phenomena that are important. So risk aversion, is that a universal phenomenon? Modulo a bit of noise that we can't ignore. Well, economists have always assumed that. And probably if you had some economic class, Mike, or the teacher, one of the first things they told you, people are risk averse. Arguments that you can find in the economic literature, why are people risk averse? Why is utility? One argument is diminishing marginal utility is plausible. And the first pound you get, you give them the best thing you can get. The second pound, you buy only the second best thing that you can get for a pound. So utility, diminishing marginal utility is very convincing. That's one argument, to assume concave utility. Also, often if you want to have nice theorems that equilibrium exists, usually you need concave utility, otherwise equilibrium might not exist and your theorems don't work well, your model. So that's another reason why economists quite like concave utility. A third argument, if utility were not concave, if people would sometimes be risk-seeking, then you should see markets for risk, well, there are a bit, but not very, lotteries, I know, horse gambling. But then people on the street should immediately say, hey, let's flip a coin, 50-50, you win or I win. You should see that everywhere if people were had systematic risk-seeking. But you don't see this so much on the street. That was another argument that economists gave. And here's one more Marshall. He wrote an argument about risks. Well, tongue-in-cheek, it was a joke, but let me still show you. This is what Marshall wrote. Experience shows that risk-seeking people are likely to engender a restless, feverish character, unsuited for steady work, as well for the higher and more solid pleasures of life. So anyway, economists don't want to hear about risk-seeking, so much we can say. And typical of all the arguments, almost all of them that you heard so far that have driven economists, they're not much based on empirical observations. People often said the last 20 years experimental economics has been better. But before, economics was quite an armchair discipline. People were not looking very much, surely at the micro level, at data and empirical observations. So any empirical test of whether people are risk averse, any empirical measurement of individual utility functions was almost absent in the economic literature. Everybody was always writing, assuming. And with psychologists, that's very different. A few problems economists were aware of, for instance, the coexistence of gambling and insurance. There is the market with public lotteries. There is some gambling industry going on. There people are risk-seeking, so that's a bit difficult for economists. And Arrow, he was one of the classical economists, Nobel Prize winner. He talked about this, and he said, I will not dwell on this point extensively, emulating rather the preacher who, expounding a subtle teleological point to his congregation, frankly stated, brethren, here there is a great difficulty. Let us face it firmly and pass on. So it's, we have a problem, we don't know what to do, let's just ignore it. There's not, it's often that, every theory there's violation. You can't give up a theory for one violation, so there's always, it's pragmatic, you have to be like that. But this was then the attitude of economics. There's a bit of risk-seeking still, but not enough to change our models. But psychologists are very different. Immediately, let's test, let's do an experiment. Since the 50s, psychologists have been doing it. Experiments, testing whether people are risk averse. Is that a universal property or not? And from the beginning, they find that is not. From the beginning, in the psychological literature, you find places where people are very systematically deviating from risk aversion. So I'll get back to that. So I want to do a little bit historical along the two lines. So now there have been experiments showing clear risk-seeking. We would have to incorporate to get good models. I'll continue on that a bit later. I want to keep it historical. Now I go back to this first question, risk attitude, how to model it. Utility of money or probability weighting or maybe something different. So that will be discussed in the end of the 1970s. So for a long time, psychologists always writing the formula, economists never looking at it. But in the 90s, then, also in economics, there came new interest, first maybe, in this probability weighting, in deviating from expected utility. And one reason was Machina 82, he wrote some influential papers, one paper in particular, really arguing that we should look at different models than expected utility. In 1982, he was very influential, and some other reasons. There was a paper by Honda in 1978, Journal of Political Economy, and there was a paper by Kahneman and Tversky, 79, in Econometrica Prospect Theory. These papers were also looking and writing formulas with probability weighting. Now, these two papers have in common that they appear in a prominent economic journal. So those papers, the psychological papers, the economists didn't look much at them. But many economists looked at these formulas and at these theories. And then happened something where we need the economists, what psychologists could not do. Because the moment economists seriously look at such formula, economists are more theoretically sophisticated, you guys. These formulas have a problem and they would quickly see it. So then this Kahneman Tversky, I don't have a photo of Honda. This Honda paper, the first one appeared 78 in Journal of Political Economy. The editor, soon after appearance of the paper, he received some 10 letters of people all arguing the same thing, being that these formulas are not correct formulas. There's something very weird about these formulas. So many people saw it the moment economists look at it. Just wrong formulas. And they published only one. Fishburne, a very good mathematician, writing very well, they published his reply. The other 9, you can't publish everything. And among the ones not published was a letter by John Quiggin, Australian. I think you guys are PhD students, right? He was a master's student, so he was even below you, if I may say so. So the journal did not look very serious at this unknown Australian guy. But he will come back later in my story. He was among the people who wrote a letter and noticed the problem. And the problem was, well, and this Kahneman Tversky paper, the one I mentioned, had a lot of attention. It's the second most cited in all the economic literature. So many people read it, discuss it. But then the problem was that that formula that I showed you, with its probability weighting, that implies automatically that stochastic dominance is violated. Stochastic dominance means if I have a lottery and I replace the outcome by a better outcome, I increase some money amount in the lottery, you must always like it. The more the better. It's just an improvement. So that's a very natural, surely a normative condition, but also empirically people, everything is violated, but not systematically. Now these formulas violate that. There are always, the moment these formulas are deviating from expected utility, bringing something new, you can always find a lottery such that if you improve one of its outcomes, the theory says now it's worth less. And that doesn't make sense. Also, empirically, it doesn't happen empirically like these formulas say. So these are just bad mathematical formulas. They don't work well. And every mathematician, for you may be a bit quick, but if you look at it for a while and you know a bit about mathematics, you see it happening. These are just not good formulas. So that was discovered at that time only, after 30 years in the psychological literature, nobody noticing. Well, needed economists to do it. So it's a bit amazing, the disconnect between empirical and theoretical. Here it happened. The empirically oriented psychologists, for 30 years, all the textbook, all the students had been reading the formula, learning it. And if you want to have it as a match between the economist and the psychologist, you could say this is 1-0 for the economist, because it's a bit embarrassing for the psychologist. For 30 years, such a mistake. But so it is. Anyway, Quiggin, so he was one of the people who wrote a letter that formula is wrong. But Quiggin did more. Of those 10 people, he was the only one who not only saw that something is wrong, but he also saw a way to fix it. And that was a very brilliant idea. And he was, well, Schmeidel had it independently for uncertainty, but Quiggin for risk the first. He saw a way to fix it. And I'll tell you a little bit, but I don't have the time to really explain to you how it works mathematically. But I'll tell you a little bit what Quiggin's idea was. He said this intuition, and he was right, the intuition that we should do something with probability, that we need a theory that does something with probability to capture risk attitude, that's a good intuition. We really need that. The expected utility, it really does not work well. We need such a theory. So we shouldn't give up. The formula we had was not right, so we should find a better formula. A formula that does the same, but in a better way. And Quiggin saw a way how that can be done. He said, weighing probability is a good idea, but the psychologists were weighing the wrong probabilities. You should transform other probabilities than what the psychologists did. And he looked very well at the formula and a good mathematical insight. So you should not, maybe you remember, Pi was a probability of getting Xi, and I was replacing Pi by WPi. I was transforming probability of getting a fixed outcome, and that was not so good. You should not be transforming the probability of getting a separate outcome. You should use a different formula. And Quiggin said, and I will not explain well, but just vaguely I'll give you the gist of the idea. You should transform good news probabilities, being probability of receiving an outcome or anything better. That's a bit vague. But if Pi is your probability of Xi, that's not the probability. But you should look at the probability of getting Xi or anything better. The cumulative probability, or the dual of the distribution function, that's the thing that you should transform. That was his insight. And then I'll give you the formula for 2 outcomes, just a little bit of the gist of the idea, not really, I don't have time for that. But here, what Quiggin wrote for 2 outcomes, let me show you. Here is a lottery giving you either capital M pounds or small m pounds, probability P or 1 minus P. The wrong formula that psychologists have been using long time was like this. there's the probability P and the probability 1 minus P, the probability of separate outcome. We just transform both of them. That they had been doing for all the time, and that was what was not right. Quiggin wrote a little bit different formula, and it doesn't look as dramatic as it is. Now comes the right formula. The right formula is that you don't take W1 minus P, but you take 1 minus WP. Now, that doesn't look probably very dramatic to you, but still it is dramatic. But underlying this is this idea, what I will not explain very much, but really this is the right way to do it. Now we have a formula that is sound, satisfies good mathematical properties, and Quiggin also extended it to many more than 2 outcomes I will not explain to you. But it turns out that this is a sound formula. This has good mathematical properties. This satisfies stochastic dominance. So only when Quiggin wrote that formula, people started using it, then it started rolling. Then we got theories, now we have formulas that work. That was the beginning, I think, of behavioral economics, in risk theory. Then we could also do theory with it. And that was the theoretical birth of behavioral economics, I would say. That idea of that Australian master student, so younger than you guys. By the way, Quiggin wrote an 82 paper with this idea, and nobody knows. He didn't write very well. You can understand, with students, it's a bit difficult. People kind of ignored it. And around 86 or 87, some more prominent economists discovered this idea again. And then a bit later, somebody discovered, wait a minute, there has been an Australian in 82 who already had the idea. So then Quiggin, nobody knows, they had to find, he was working somewhere, they found him, they invited him. He had already left academia because now suddenly he was famous. So if you write a paper, nobody pays attention. Maybe 5 years later, you're working somewhere else, you get a letter or an email, and you will be famous. It can happen to you like it happened to Quiggin. But surely he got now, everybody's famous, he got his respect for this great idea he had. So now, for the first time, we have a good formula, a good general formula. This first line of my talk, how in general should we model risk attitude? Now we have a good idea. Now we have an idea that does it with probabilities. This, everybody can feel intuitively, I think, that you should do something with probabilities. Now we have a good formula. Quiggin brought it, started it. A bit later than Kahneman, Tversky, prospectively incorporated, everybody started using it. Now let's go back to the second line of my talk. What are the empirical... I think my watch is... No, it's right. What are the empirical phenomena? A risk aversion, is that universal, or should we look at more variation? So I already told you that economists took risk aversion as universal for all kind of pragmatical reasons, not having much to do with empirical findings. And when Quiggin introduced his idea, so that's why I had the 2 lines, how I told. Anyway, Quiggin introduced this good idea of probability weighting. People started using his formula, but first economists started using it. You need theoretical sophistication, and economists didn't really have the right empirical phenomena in mind. They were much, and even today, economists usually only think about risk aversion. So when economists started using that good idea of probability weighting, they would usually combine it with universal risk aversion. So they would come with curves like this, because this is a probability weighting for, I will not explain, you take my word for it. This kind of convex shaped probability weighting, that is what fits with risk aversion. So economists were always studying these kind of curves, these kind of attitudes, and many theoretical papers and game theory, all kind of applications, usually looking at such kind of curves. To get the right curves, to get the right empirical phenomena, then you need empirical realism, and that came historically from the psychologists. That's why the field really needs the input from psychology. That's why behavioral economics is now developing so much, and here you see it happening. To get the right phenomena was Kahneman, Tversky, and other psychologists. They showed what is really going on empirically, and what shapes of probability weighting we should use, not those shapes. Because every experiment since the 1950s that looks into it finds that there's systematic risk seeking, for instance, for small probabilities of large gains. People overweight small probabilities. That means if you play in a lottery and you have a probability of 1 over a million of winning £1,000,000, and you're feeling 1 over a million, you feel it like 1 over 1,000 maybe. People are overestimating, they don't understand how small probabilities are. People are usually overestimating small probabilities. That's why people are usually risk-seeking for small probability, large gains. Every empirical study shows it again and again. It's too strong and too much to ignore. That's one reason why we have to give up the assumption of universal risk aversion. This is too far from Homo sapiens to maintain. Another case for losses. If we work with losses, overall for losses people are more risk-seeking than risk-averse. Now that's quite different than what your micro teacher taught you probably. Probably he told you in one of the first class, he told you people are risk-averse, insurance, losses. Well, it's a bit subtle, but for losses, there's more risk-seeking than risk-aversion that we find empirically. Actually, for the moderate and the high probability losses. For the small probability big losses, people are still risk-averse because they overweight those probabilities, and that's why insurance is taking place. It has nothing to do with utility. It's the overweighting of the small probabilities. Well, many other things beside the model, but within this theory, within these models, that is what drives the insurance. So very different than what every textbook, what all your teachers have been telling you. But this is what every empirical study finds. Now the prevailing empirical shape of probability is like this. In the beginning there's overweighting, and then only for moderate and high probabilities there's underweighting. And this overweighting, I didn't show you the formula of it, you can, but you take my word for it. That overweighting in the beginning, that is the risk seeking for small probabilities. So this is the shape that we find empirically. And this is therefore the phenomenon that we should try to study to understand what our consumers are doing. And here you can say it's amazing that this assumption of universal risk aversion can have been surviving in the economic literature for 30 and maybe even up to today, whereas every empirical study is finding other things. So here you could say if it's a match, you could say this psychology is level here, 1-to-1. So really your both inputs, both fields make mistakes, but together, really this, where we are on risk and uncertainty today and in general, I think we really needed all these inputs for all these fields to get here. So then the synthesis for risk. And Tversky Kahneman, 92, they wrote, I'd already told you in 79 they published a paper on prospect theory, the second most cited paper in the economic literature. Then John Quiggin with his insight came only after, and only a few years later Kahneman and Tversky heard about the Quiggin idea and they were very happy. Now we can write prospect theory in a better manner. So in 92 they wrote an improved version of prospect theory that uses the Quiggin idea. And now they got the formulas completely right. 79 the formulas were not really right. So this was sort of the synthesis of all of it. Good, and this is still today, I think, the leading theory in decision under risk, prospect theory in the new version, combining all the good inputs of the field. So it has, well, utility plays, especially for big amounts of money, utility curvature does play a role for risk attitude. But surely how people feel about probability you should also have. That psychological intuition that they had from the beginning, that is kept in this theory. That's one good thing of the theory. And loss, I didn't explain it, loss aversion. I will not explain everything today, but that was something else that they needed and got done in their theory. Risk aversion is prevailing. There's more risk aversion than risk seeking, that is true. But there's so much systematic risk seeking in all kind of contexts, you can't assume universal risk aversion. That's too far from Homo sapiens. They get that right in the theory. I will not explain, they had a reference point, reference dependence. But anyway, their theory combines the descriptive insights of psychologists in the 79 paper and the whole literature of psychology, combines with the theoretical insight that came from economists, that Quiggin brought and other economists, and also Gibor, Schmeidler, people. And all of that was combined. So this theory was the first, I would say, this was the first mature, then behavioral economics became grown up. 79, I would say, is the birth of behavioral economics. That first paper of Kahneman and Tversky bringing in these psychological things in economics in a way that economists can read, because of formulas. That was maybe the birth of behavioral economics, but it still was a baby, still had to grow. And here it was the first time something that can really be used, that really works. So this, I would say, was behavioral economics became mature, should be taken seriously from then on. It started in decision under risk, and then spreading these psychological insights in all fields, intertemporal, and I don't know what field everybody here is working on, but in your field I expect it will also come, and I hope that you will contribute to it. One more novelty in that theory, and that brings me to the second part of my talk, Also in the 92 paper, they could handle ambiguity, and I'm going to discuss that now. So two parts. The first part, the history of risk, and I told you, I think since we have prospect theory, we have a good theory, and that's still the prevailing theory. But now we go to ambiguity, unknown probability. And that is happening much now, and maybe, I don't know what, I think almost every field in economics in the past, we always assume probabilities. Now we're going to get ambiguity theories, and in many of your papers, I hope in the future, that to happen. The problem of ambiguity was put on the table by Keynes in 1921, Economist, and ambiguity means that you don't know probabilities. Keynes and Knight, they were already so long ago, almost a century ago, they already pointed out that in those days, most people in economic models are assuming probabilities, but usually in economics we don't know probability. And that's a bit typical of economics. Maybe in health and medicine often we know probabilities. But economics usually, like inflation going up next year, what's the probability of that happening? We don't know, it's uncertain. But we can't say probability, because the economy is now in a state that was never before. With macroeconomics, you can't do experiments. And in many decisions, saving decisions, the market is different than ever before. Usually, almost always in economics, we don't know probabilities. If you know probabilities like insurance, you can average them out, you can hedge premiums, everything can be done. And Knight wrote, the real businessman, if you don't know probability, then you must really show that you're a good businessman, that you can handle uncertainty. Then it is really difficult, what should you do? Already Knight emphasized it. Since 1921, almost everybody knows that in economics this is important, we should handle it. Some first reactions to this came, this is Keynes, by some people, De Finetti, Ramsey, Savage. The first people who thought about this question of unknown probability, well, it had been also previous centuries, but in reaction to this, in economics, these people said, well, there are indeed many situations in which we don't know probabilities, we don't have objective probabilities, but then in such situations we should still use probabilities. We should use, because they are not objective, let us call them subjective, your best guess of probabilities. And they gave, it sounds a bit naive, if you have no objective probability, plug in whatever is the best guess and go ahead. But there were deep works, deep thinking, axiomatization, justify it. So this was the first reply. And for a while, economics thought, okay, we can live on like this. We can do what we always did, only we use subjective instead of objective probabilities. So no big deal. Well, so the question of Keynes and Knight was put back on the table. So here are the photos of the three, De Finetti, Ramsey, and Savage. Then Ellsberg, 61, he put a paradox, he published a paradox, I have no time to explain it. That put the question of Keynes and Knight on the table again, because this paradox shows that the ideas of these people don't work well, I mean empirically. He gave some examples where almost everybody is violating the conditions that these people set. So a recommendation of these people to use subjective probability, it just doesn't work. We need something more fundamentally different. And Ellsberg, maybe some people may know him from politics, he was a very influential, secret papers in the US. Anyway, but also in the decision theory, he was very influential. Because after this it was clear we need something fundamentally new for uncertainty, ambiguity. We cannot get by with probabilities as we did on the risk. We need fundamentally new things. There is him. Anyway, so from 21 and surely from 61 until 1990, and always many people have known, I mean, I don't know in what field you guys are working, if you write probabilities, maybe in every application usually you don't know probabilities. And many economists have known we should handle ambiguity, we should know how to do it. For a long time it didn't happen because people didn't know how to do it. And only when some very clever people, the end of the 1980s, well, Guibot and Schmeidler mostly, they were very creative, because think of a model how to handle if there are no probabilities. That's really weird, how could you do it? It's so hard. But they found a way to do it. They introduced decision theories that can handle ambiguity. They showed for the first time we can do sensible decision making still. There they are. And then the field could take off. And here again, you know, the right formulas, these were economists. That's a theoretical thing, to find the right formulas. Economists, they did it. They brought the new theories. And then only it could start. Around 1990, we could start thinking about ambiguity, that we may be able to handle it lots of catching up. There are many economic questions, and only now we have the tools, so much to catch up. It's really popular nowadays, ambiguity, so maybe you will want to work on it also. Anyway, the right formulas came from economists, but economists didn't have the right empirical ideas, because economists, there's always risk aversion, ambiguity aversion, then you have equilibria. And again, even today in the economic literature, now it looks a bit weird what I show you now, but the common thinking in theoretically working economists, this is going on today. History of risk is repeating. I think at this moment in the ambiguity field there's a clear disconnect between theory and empirical findings. Almost all the economic theoretical papers, they look at the Ellsberg paradox, they think ambiguity aversion. They're only working on that. Always universal ambiguity aversion, that's the big thing. Don't look at data. History is repeating itself. That's happening for your generation. Already in 92, so that's now 25 years ago, there was a survey paper by Kammerer and Weber, and they already were complaining, already in those days, quite early, people are so much focusing on the Ellsberg urn. They said there are decreasing returns to studying urns. We should look at other events, natural events, look empirically what is happening. Now 25 years later, still not so much happening. And another thing, the question, how should you in general model ambiguity attitude? The most popular model today is what I write here. I'm not going to be very diplomatic now for my colleagues, sorry to say, but this is what is called the smooth model. That's a model that is trying to model ambiguity attitude through utility functions, how people feel about outcomes. And I see it happening, and I think we had that in the 80s. For risk, we saw it doesn't have work. Risk is how people feel about probability, not outcome. Ambiguity is how people feel about events, not about outcomes. So I think, remembering I was a young guy in the 1980s, I saw it happening. Here, immediately, I think this cannot work. This is a theory that's, well, ambiguity is about events, not about outcomes. But still, it's the most popular because it's easy to use. That's a big reason. And some other people also wrote papers on that. So here, history is repeating. Some people have criticized. I've also written a critical paper on that. But okay, we stand by history, see it happen again. The second line, the empirical findings. Already, here is Einhorn and Hogarth, Psychologists 85, long ago. And every empirical study finds there's much ambiguity seeking. So much you can't assume universal ambiguity aversion. There's systematic ambiguity seeking for unlikely small probabilities, people are risk seeking. For unlikely events, people are ambiguity seeking. For losses, people are more risk seeking than risk averse. For loss, people are also more ambiguity seeking than ambiguity averse. So history is repeating itself, and all the empirical studies find it again and again. But still the theoretical literature is not yet catching up. So the connection that took place in the risk 20 years ago in ambiguity still have to happen, and the right applications will force this to happen, and that's the task for your generation to do. So I hope that better connection will come in the future than were there in the past so far. And here again, if we score, this is amazing that the assumption of universal ambiguity can still be prevailing in economic literature today, with all the empirical findings being so different. So then, I'm working on that. A little bit I say about my own things. How I work on ambiguity, I try to connect them. It doesn't. It stopped functioning, it seems. Oh, there, it works again. Yeah. Anyway, actually, I think I'll skip this. So I'm working on something called the source method, but I think I'm going to skip it. I want to go, and I'll skip the summary. Let me now, in the time left, go to conclusions from my lecture for you guys. So one conclusion is that it's useful, whatever field you're working, uncertainty, risk will play a role. Try to see what happens if you don't know probabilities. Try to see how in your field you're working with unknown probability ambiguity models, what you can do. That's something economics really has to catch up with in almost every field. That's one conclusion I hope to convince you of. try to get your agents to behave like Homo sapiens and less like Homo economicus than it was in the past. And Homo sapiens, how people really behave, psychological papers, there are all kind of biases, deviations from rationality, emotions playing a role, altruism, all these things are being used more and more, the behavioral things. And I hope that you will also do it in whatever field you are working. And then theoretical, that people, if you work on theory, that you still try to see if it's empirically realistic what you assume. And if you work empirically, that you know a bit about underlying theories. Many mistakes from the past could be prevented if this were done better than it had been done. And then for this conference, I'll be here curious to see lectures to come and how many of your lectures will already have behavioral inputs and ambiguity. I'm very curious to see that in the lectures that will come. And hope that, if not now, that in your future works, you use a lot of these things, because it's a good direction to go, the behavioral approach. And that's at the end.